So, welcome to Civil Engineering Online. So, subject is Design of Pre-stressed Concrete Structures. So, module number 2, Deflection of Pre-stress. Topic is Problems on Deflection of Pre-stress. So, problem number 5 for deflections. So, a concrete beam with symmetrical I section has flange width and depth of 200 mm and 60 mm respectively. So width of the I flange is 200 mm, depth is 60 mm. The thickness of the web is 80 mm and overall depth is 400 mm. The beam is pre-stressed by a cable carrying a force of 1000 kN. The span of the beam is 8 meters. The center line of the cable is 150 mm from the soffit of the beam at the center of span, linearly to 250 mm at the supports. Compute the initial deflection at mid-span due to pre-stress and self-weight of the beam, assuming EC is equals to 38 kN per mm square. Compare the deflection with the limiting deflection permitted in IS 1343. Density DC is equals to 24 kN per meter cube. So in this problem, I section is given with a symmetrical type, wherein they have provided us flange width, depth, and thickness of web and overall depth. So let us find out the solution part. So in this, the figure will be like this. So 400 is the overall depth, 200 mm is the flange width, and depth of the flanges is 60 mm. Web thickness is 80 mm, what the provided in the question. So with the calculation of area of this figure and then multiplying with the area and density as calculated the self weight of the beam directly, G is equals to 1.12 kilonewton per meter, which comes out to be 0.0012112 kilonewton per mm it is. So try to calculate the area of this particular I section and multiply it with density 24 kilonewton. Pre-stressing force P is equals to 1000 kilonewton as provided in the question. Moment of inertia I is equals to 847 into 10 raised to 6 mm raised to 4 for this I section. E is 50 and E2 is also 50. So how is this 50 and how is this 50 mm and this is how it is 50 mm will be shown to you in the next figure. Span is L equals to 8000 mm. So this is the figure part of the particular question, where in I section this is the center of the cement, that is center of gravity. Here this is the top flange dotted line, this is the bottom flange dotted line. So here at this bottom it is having 150 mm from the soffit, and from at the supports it is having 250. So this is CG from the center of this part is E1, which we'll consider as 50 mm. So here it is again above the CG, which will be having E2 as 50 mm. So here it is 150, here it is 250. So it is able to see that from here to here it is 150. From particular this center point to the end point of the uh, cables at the supports is again plus added 250 from this point to this point. So in between the distance will have of 100 mm. 250 minus 150, so this is 50 mm, this part is 50 mm. And loading, how we are going to consider is like this. For the particular deflection, one is regular deflection will be acting, and one more part is the deflection of triangular shape is going to act in the member. So deflection due to the self weight of the beam is this only, delta dl, which is self weight 5 wl raised to 4 384 ei. So substituting the values into this, we found it as 1.86 mm in downward direction. B. Deflection due to the pre-stress delta PS is equals to P E2L square divided by 8EI minus P in bracket E1 plus E2L square divided by 12EI is the formula for this type of particular cable profile. So this formula we need to understand and remember. Substituting the values. So here we have made it PL square and EI common from both the conditions. So this is PL square EI. In bracket is remaining only E2 divided by 8 minus E1 plus E2 divided by 12. So this part is the part of E1 divided by 8 minus E1 plus E2 divided by 12. So value comes out to the deflection in the upward direction is minus 4.1 mm acting in upward direction, which is due to pre-stress. So deflection due to pre-stress plus self-weight is minus 4.1 plus 1.86, which is minus 2.24 mm acting in the upward direction. Maximum permissible deflection according to IS 1343, so which is equals to span divided by 300 is 8000 divided by 300. It comes out to be in upward direction 26.6 mm acting in upward direction. Hence the actual deflection is within the permissible limit. As it is a minus value, here it is a positive value, we are able to have it within the permissible limit of the IS 1343. So this was the deflection problems got ended. Thank you for watching, and the part of further portion will be covered with the new videos from next video. So for having a great experience, like, share and subscribe the channel. Thank you so much.